All right, bear with me for one last example, yet another free response question, because who doesn't love them? So in example 11, Johanna jogs along a straight path for 0 is less than or equal to t, which is less than or equal to 40. Johanna's velocity is given by a differentiable function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Okay, well, what's the question? It's right here in the margin. It asks, use the data in the table to estimate the value of v prime of 16. What the heck does this have to do with integrals and rates of change and all of that? Absolutely nothing. However, the next part of this question will. So just bear with me. I just wanted to use this as an opportunity to kind of recap something that they would expect you to do on the calculus exam. So we do not have an equation here in order to find the derivative. All we have is a table of values. It does say to estimate it. How do you estimate a derivative? Well, a derivative is a tangent line, and we estimate a tangent line with the closest secant line. So for 16, which is not in the table, but 16 lies like right up in here, I'm just going to use the closest secant line, which would be from 12 to 20. So what I'm just going to do is find the slope between those 2 points, and we're going to use that to evaluate, or I should say approximate, the value of v prime of 16. Should be approximately equal to, use the correct symbol, and a change in y over a change in x is going to be 240 minus 200 over 20 minus 12. You could reduce that. I think we can handle that. Let's see, we got a 40 up top and an 8 gives us 5. Let's go ahead and throw in our units. Up top, we have meters per minute, and on the bottom, we have minutes. So this is going to be meters per minute, or if you prefer, meters per minute squared. Okay, all right, so let's see what this has to do with the current lesson, shall we? It's on the second part of this. Using correct units, explain the meaning of the definite integral from 0 to 40 of the absolute value of v of t in the context of the problem. Okay, so this is exactly what we we're just talking about in the last lesson, or the last video, I should say. If I take a definite integral of an absolute value of velocity, this is supposed to give us the total distance. Now, within the context here, Johanna jogged in between the time interval from 0 to 40. From t equals 0 to t equals 40 minutes. Okay, and that's about it. Now, is it possible that they could ask us to evaluate this? It absolutely is. And how would you do that since you don't have an equation? Well, they could ask you to approximate it with something like a Riemann sum, and that Riemann sum could be a left Riemann sum using your left endpoints, or a right Riemann sum, which would use your right endpoints, or possibly you could use a trapezoid sum. You just have to pay attention to whatever it is that they're looking for. All right, that wraps up our lesson here on indefinite integrals. And when we're talking about indefinite integrals, honestly, that was just the first objective. Indefinite integrals is the same thing as finding an antiderivative. And then if we reinterpret the fundamental theorem of calculus, we can see that if we take a definite integral of a rate of change, we can use that to find the net change in some sort of quantity.